Hi. I hope you're having a great weekend. This is the first attempt at what we're calling our flipped classroom. We're going to try something new this week. So instead of you getting the instruction from me in class, you're going to have this video that you're going to watch sometime this weekend. And if you've already found it, you're in good shape so far. And you're going to be getting the lesson through the video. And then when you're in class, you're going to have the opportunity to do the normal journal pages, but also work on the homework page that you would do at home. Just trying something a little bit different. As you're aware, I won't be there on Wednesday, Thursday, and Friday this week. So this is my attempt at still being with you and giving you the instruction that you need with our math lessons, but also taking those 3 days, unfortunately. So I will miss you all. Today we are going to be starting the first lesson of our new unit. We're going to be starting Unit 5, which is Area and Volume Explorations. And the first lesson that we're going to be working on, Lesson 5.1, is Polygons on a Coordinate Grid. So you're going to see me in your bottom corner of the page. I might move around a little bit, or it might just be my face. Hopefully not, because this is just too weird for me. But the majority of the lesson will be in front of you through, I'll be going between two tabs. You'll see a Google slide presentation, and I'll also be doing what we usually see in class, our Connect Ed presentation as well. So we're going to start here. This is, like I just said, we're doing Unit 5, Area and Volume Explorations, and I'm just going to use the same pages presentation for the 5 lessons that you're going to be receiving through this flipped format. I'm going to try to do this in one take, so I'm going to mess up and cough and all that fun stuff, and one of my kids might pop into the room, but we're going to do our best. So like I was saying, first we're going to start, just like we do with most of our lessons, with going over the objectives. That's what you're going to see next up on there on the screen. So you'll see Lesson 5.1, Polygons on a Coordinate Plane, and I'm going to go away from my face. Let's see if I can do that. So it says, today I am drawing polygons on a coordinate grid and finding the lengths of their sides. Why are we doing that? So that we can calculate side lengths using absolute value. And today you'll know you've got it when you can successfully use the patterns you've found among the absolute value number models to calculate the lengths of the sides of the polygons. So just always checking in with your understanding throughout our lesson. This is where you should look to make sure that you've got what we've presented to you. We're going to have you turn to your journal, and I'm going to click over to the Connect Ed presentation. Okay. So if you could turn to your math message, page 238 of your journal. I'll give you a second to do that. And then I'm going to go back to that pages presentation, because I'm going to go over a few things that page assumes that you have your student reference book, but we all know how well you are with bringing that back and forth to school, but that's okay. So you'll notice on page 238, it says that it's asked you to review the descriptions of polygons on student reference book, page 238. So I'm going to do that for you here on this Google slide. So it says, a polygon is a flat, two-dimensional figure made up of line segments called sides. A polygon can have any number of sides as long as it has at least 3. The interior, or inside of a polygon, is not a part of the polygon. The sides of the polygon are connected to make one closed path. The sides of a polygon do not cross. Each endpoint where two sides meet is called a vertex. The plural of vertex is vertices. So this is what you would have read on page 238. So what I would like you to do, you're going to complete your math message on your own. Maybe you can talk it over with someone at home if you'd like. But it asks you to find polygons in the faces of objects around the classroom. Obviously, you're not in the classroom, so you're going to be looking for faces of objects around your home. Let's talk about a face of an object. A face is any flat side of a 3-dimensional or 2-dimensional, obviously, polygon. So anywhere that you see a flat side of a polygon, either 2-dimensional or 3-dimensional, I'd like you to sketch that here. Okay, so it says sketch or list at least 4 objects. Part B then asks you to list the names of some of the polygons you found. So again, part A, you're doing the sketching of about 4, and part B, you're going to be listing the names of those polygons. This might be a good time in the presentation for you to pause so you have some time to look around your house, sketch some of those things that I've asked you to look for, and then also take some time to reflect on those shapes that you see, those polygons that you see, and maybe see if you can list the names, those exact names, those definitions, or not the definitions, of the vocabulary words that we use to define those types of polygons. So again, hit pause, and then you can complete that. Well, if you're seeing that little email pop up in the top hand corner, someone is replying to McCoy's birthday party. So that might happen now and then. So now we're going to go into a little bit of a reflection from your math message. So if you're coming back, these are some of the polygons that you should have listed from the shapes that you've recorded and sketched from around your house. So we all know a triangle is a 3-sided polygon. We have that quadrilateral. We have a 4-sided polygon, and I have opposite sides that may or may not be parallel. We have a pentagon, 5 sides, hexagon, 6 sides, octagon, 8 sides, and then the square, obviously we know, is a 4-sided figure that all of our sides are equal. And I'm going to add rectangle up here too. Not sure why that one wasn't added originally. It's also a polygon with those 4 sides, and it could also be another description of a quadrilateral. Okay, so this is some of the things that you should have listed. We're going to jump back to the Connect Ed presentation, and here, let me move myself out of the way here. What we're going to take a look at now is some of the things that you're going to need for today's journal pages. So this will be the direct instruction portion of our lesson. So what I'm going to have you take a look at is, let me find it on my screen here. No photos. We're going to review how to accurately list and describe segments of those polygons that we're going to be working with today. So here you'll see rectangle, and we make sure that when you're reading a rectangle name that you say all of the letters in order as they would be connected together. So you could say rectangle E, H, G, F. You could say rectangle E, F, G, H. You could say rectangle F, G, H, E. You could say rectangle F, E, H, G. You get the idea. So over to the left of the screen, I have actually listed the correct way to list segments of these polygons that we're discussing today. So you'll notice when I'm talking about segment EF, this is this vertical segment here. And the correct way to do that is we use those capital letters, and we draw a straight line above the 2 letters showing that that represents a segment. Here we have segment EH, we have segment HG, and we have segment F. Oh, segment FH. Is that a segment? No, that's an error. So we want to correct that here. The correct segment that should be listed there is F. We have EF, we have EH, we have HG, we're missing GF. So that's what that should have said there. So we're going to correct that here. That should say FG. Capital letters. And there we go. Okay. So this is the correct way to list those segments that we'll be working with today. Okay, so make sure that you have those lines above it. The next thing that we're going to talk about, and I'm going to go back to the Google Slides presentation, is you'll notice when we're graphing coordinates, so this is a review, again something that we've done since Unit 1, is when we're graphing coordinates, remember that we always want to walk to the ladder before we climb it. Whenever I'm graphing coordinates, we always want to make sure that we graph the x coordinate first and then the y coordinate second. So I should always move right or left first and then up or down following that coordinate movement. We always start at the origin, which is 0, 0 on our coordinate plane, and from there we move according to the number of spaces that's listed for us. So here you'll notice our first coordinate is 5, 3. So our x coordinate is 5 and our y coordinate is 3. So we're going to practice graphing that coordinate together. So I'm going to pick up that dot. Again, I'm going to start at the origin, so I start at 0, 0. Now that x coordinate is positive, so I should move to the right to the positive coordinates. 1, 2, 3, 4, 5. My second coordinate is a 3, so I should move up to the positive coordinates 3 spaces. 1, 2, 3, and you'll plot your point there. Okay. Usually you're given a letter to plot those points with, so say this was point A, so next to that I would draw a capital A. My next coordinate that I'm going to be plotting is -4, 2, so a little bit different because I have the negative coordinates here. So again, I start at the origin, 0, 0, but instead of moving right 4 spaces, because it's a negative value, I'm going to move to the left 4 spaces. 1, 2, 3, 4, and I'm going to drop that dot. Then it's a +2, so I should move up to the positive coordinates. So again, I'm going to pick up that dot and I'm going to move 2 spaces, if it lets me. Oh, what did I do to it? Okay, I'm going to pick up that dot and I'm going to move 2 spaces up. I think I just made it really skinny. Let's see if I can fix it. Okay, so that should be, oh, it's close, we'll fix it. Okay, so that should be at -4, 2. Just a reminder of how to graph those coordinate points when you're plotting them on the plane. So today you're going to be working in class. You're going to be working on plotting some polygons with a partner, and then you're going to have the opportunity to work on your homework page. Okay. When you're working with calculating the side lengths, just a quick reminder for something before you move into it later. When you're working on calculating the side lengths of a polygon, should they ever be negative? Hopefully you shook your head no, okay? It's a physical space. It's something that we're going to be counting. So even though if I'm going to be plotting a polygon maybe down here in this quadrant, and those values might look negative, when I'm counting the side lengths, I should always use a positive value. So keep that absolute value in mind that we've been working with when we were discussing counting those physical spaces and working with absolute value. So just wanted to make sure that I said goodbye. Hopefully this was a successful first go with our flipped classroom. I'll get better at it, I promise. So I will see you tomorrow night for your 5-2 lesson. See ya!